So, borrowing from the introduction of this section in our textbook, I went online and actually just searched the U.S. Department of Labor, the wage and hour division. It just gives you all of the minimum federal, at the federal minimum wage rates. It goes back from 1938, I believe. 1938 till 2009. And at various points throughout that time, the federal government set the minimum wage rates. I know some of you weight tables, and it's a little bit different, but you can look at what those values should add up to. But it should still be up to equivalent to the 7.25 dollars an hour now as of 2009. It hasn't been updated federally since then. But what this graph shows is obviously something that's not continuous, and I don't think we need to really go into too much detail. I'm pretty sure most of you can realize that something to be continuous means there shouldn't be any breaks. That's part of the no-brainer. But what I want to get to, because we'll see it a little bit later in the average rates of change, and then more specifically the instantaneous rates of change, is we don't necessarily have to be talking about continuity over the entire graph. Sometimes we can just talk about continuity over a specific interval and think about it as we continue to zoom in on a small and small enough section. We get this nice linear look, obviously in this case, but even if you want to think about the curve of a graph that's not linear, if you zoom in close enough, it's pretty much straight. Our own horizon does that. It looks pretty straight, but if you zoom out far enough, you see obviously that the Earth is round. But from our zoomed in perspective, if you look across the horizon, it looks pretty flat, like a flat line. And we'll reference that quite a bit over the next couple of weeks. But specifically for this one, I just wanted to talk about how to read the graph. Sometimes people look at these and are like, nope, not going to do it. So all this just says is in 1997, the closed dot says that it is actually for 1997, and it's this value. And I gave the numbers off to the side because obviously my sketch here wasn't going to be, obviously you can't tell that that's $5.15 exactly. So off to the side, I just wrote, the values, and again, I just got these offline. But in 1997, the minimum hourly wage was $5.15. There's a note that says that some states, cities, counties set their own minimums, so some of them are a lot higher than this, but this is the absolute minimum that anyone could have had you work for at that time. So in 1997, it would $5.15. And so the straight line across just tells you that for every year in between. So I know a lot of times our eyeballs, we're just looking here. Or if we're talking about the x-axis, we're just looking down here. But when we're talking about anywhere along this line, we're also kind of looking at the bottom part of my pencil here. If I were to keep this straight, any point on this line is tied to something on the x-axis. So if I were to try to find the year 2000, probably somewhere closer to 1997 than 2007, but the year 2000 would also have the exact same wage rate, so $5.15. It wasn't until 2007 when they raised it to $5.85. So what this is showing us, the closed circle, and kind of getting an idea of our limits, is as I get closer and closer to the year 2007 from the left side, so from the 1997 designation there. So to get as closer to 2007, I mean, you can think about Christmas of 2006, New Year's Eve of 2006, the countdown, literally the 10-9 ball dropping, all that fun stuff, to 2007. But as soon as it hits midnight, we're no longer on this level. In 2007, it jumps up to $5.85. Now, technically, I don't think that actually happened until July of 2007, but again, just for analogy's sake, when we're talking about approaching one of these closed circles, we're talking about getting as close as we physically possibly can, but then at exactly the 2007 year, or in our case, literally, sometime in the year 2007, it did bump up to $5.85. And then for the entire year of 2007, sorry, my increments down here are probably not to scale, but for the entire year of 2007, so now all of the months within there were $5.85. And then again in 2008, getting close as possible to the year 2008, but not including it. But then in 2008, the actual function value jumps up. So we call this a jump discontinuity. They're not very creative, are they? It's not that. They're trying not to be confusing. And what I mean by they, I just mean in general, people who discuss calculus or in general these types of discussions are trying to make sure that the reader isn't as confused as might seem. But in the year 2008, it would correspond to this level, and that would be the third jump there, so 655 everywhere in 2008. And then in this case in 2009, sorry, I need to fill in my hole there. So actually in 2009, it jumped up to 725. And so in that case, for 2009, the function value was 725. So the minimum wage rate was 725. And then the arrow just says for the next foreseeable future. It's 10 years later and they still haven't raised anything on the federal level. So will that arrow continue on forever and ever? Probably not. But for the sake of this table and for this graph, it does. So again, kind of talking about more relative to that area. So again, if we were to say, what's the limit from the left of 2009, I wouldn't start way back here at 1997. Definitely wouldn't want to start way back at 1938. We would want to start closer to 2009. So we would kind of restrict that side of the graph and we would look at the little segment here. So again, in reference to that. So just wanted to kind of help show those. A lot of these questions in this section are just going to talk about the idea of continuity, and really the reason why is where it gets down to this third portion in our criteria. So the function is continuous at a specific value if all three are there. So if the function is defined, so again, this notation is just the function at x equals c. So the function value at c is defined to be some value. So like with our graph, the function at 2009, so f of 2009 would equal an actual value, 7.25. We're not going to go to the open circle because that doesn't pertain to 2009 onward. It pertains to the year prior. The second criteria is that the limit of the function exists. So in this case, there's no denotion of a left or right there, meaning that it's a two-handed limit. So on either side, the limit exists. And the limit has to equal that value, and that should make sense. Again, they're not trying to be obtuse here, except for, and I copied it straight from the book just because I think it's completely outrageous that they have to say this. But if it's not continuous, then it's discontinuous there. Again, I don't know. I don't make this stuff up. I just teach it. But I hope that it makes sense. But we do have to be very specific in certain terminology, because later on when we draw on these conversations, we need them to be pretty exact. So what we were saying, so let's say we're talking about 2009. Obviously it's not continuous because there's a jump there. But this is where we could say the limit from the left is different from the limit from the right. So the limit at 2009 does not exist. However, if we were to go back to, like I said, the year 2000, the limit from the left would be $5.15. The limit from the right would be $5.15. The actual function value is $5.15. And we'll notice there's a nice continuous line. The example from the previous section, actually, there's one place where we had that jump discontinuity here. And this is where it gets a little tricky, because obviously it's not continuous. But if you were just to say, oh, the limit exists because the limit from the left and the right are the same, but the function does not exist at 3.4 at that value. It actually exists at 2. So this would be an example where physically it shows the discontinuity. But if we were to look at something again where we don't have an equation in front of us, this is where it's really important for you to know those general functions. So knowing where a rational function is undefined, knowing that a quadratic equation is never discontinuous. It's continuous on its entire domain, and those kind of things just from the shape of the graph. And we'll need that a little bit more later on in this class. But the idea is, and it kind of comes down to this last one, you kind of use this as almost a sub idea, is if the limit or if the function is continuous, then the limit of x approaching that value is just the function at that value. So if I did know the equation, let's say x squared minus 4, I know it's continuous on its entire domain. So if I were to ask what's the limit as x approaches 1, I would just plug in 1, because I don't have to worry about making sure of all those criteria are met. So again, we'll see this a little bit more as we go further, but again, the idea is just kind of putting the notation to the graph, and then recognizing that sometimes one is easier to deal with than the other. But in the case of our graphs here, obviously it's pretty straightforward why, if we can kind of, if not given one, visualize a graph, a lot of times that makes a lot more sense for us.